Okay, good morning, everyone. Okay, how did your homework go? Any questions from the homework? Please get started. Okay, so first let us recall the main two vocabulary words from yesterday. Sorry. All right, so while we remember them while we are doing the problem. So let us look at number 7. Okay. So number 7 tells me sketch the graph of a function that have a local max. So f has a local max at a point where the derivative is 0. So local max, of course, at a point A where the derivative is 0. Oops. Okay. Okay, so how can I sketch a function who has a local maximum, okay, at a point where the derivative is 0? Okay, ideas. So they want it to be a local, they don't want it to be an absolute. So has any idea how can we do that? Okay, anybody, just tell us in word, how can you do that? So we want a local maximum at a point. So it's my graph. This is a point A. This is a point on the graph where the derivative is 0. So it means right here I have a horizontal tangent. That's what it tells me. And I want to make this into a local maximum. How can I make this into a local maximum? Not an absolute one. How can I play a little bit around with a graph to make this into a local? Any idea? Whoever any idea, you can unmute and tell me what to graph. So I want a local max. It means at this point, I want something like that. That's what a local max. Okay. Now I don't want to be the absolute max, so I don't want. I'm not gonna let it go like this. I want it to be local. So how can I graph it so this will occur? Please, ideas? One end can curve back upward. One end can curve back upward. Okay, and I'm done. Absolutely correct. This is a local max. It's not an absolute max, and that's absolutely fine. So we can just play around with the curve so to stop it from having an absolute maximum. Okay. All right, so let's have a look at, of course, as usual, we don't do all of them. Graphing is actually kind of nice. Let's look at the number 11 problem. And here they give us a graph, and they want us to identify the absolute max and an absolute mean. Okay, so this problem is done. Let me see if I can get this up here for us. Okay, that's not too bad. So this is my function. They want to identify the absolute max and then the absolute mean. Okay, absolute max is where the function have its highest value, and absolute mean where it has its smallest value. So on this interval, the maximum value is obtained right here. That's the absolute maximum. So the absolute maximum is f of b, and it's obtained at x equal b. absolute minimum right there. It's f of C2 and it's obtained at x equals C2. Okay, so that's the absolute max and that's the absolute mean, the largest and the smallest value of the function. Okay. All right. So number 19, I'll read it. And again, we have to sketch the function. They want us to sketch a function. It have the following property. We're going to sketch a graph of a function on the closed interval 0, 4. So that's my domain. Means I want my function here on 0, 4. And I want to satisfy the following condition. I want the derivative to be equal to 0. It means we have a horizontal tangent for x equal 1 and 2. So we want it to be 0 at 1 and 2. And we want it to have absolute maximum at x equal 4. We want it to have an absolute minimum at x equal to 0. And we want to have a local mean, local minimum at what else? At x equal to. Okay, so we want a special behavior at each one of those values. So we want the domain 0, 4. At 1, and this is say 2, we want the derivative to be 0. So we want the slope to be like this. So the function has to look somewhere like that. That's what we want. We want an absolute max at 4. So we want the highest value at 4. The absolute mean at 0. So we want the smallest value at 0. And we want a local minimum at x equal 2. So we want it somehow to, somehow at 2. So this is the absolute mean and this absolute max. So at 2 is local mean. So it should be somewhere in here, in between. Okay. And they didn't tell us anything at 0, so we can do whatever we want at 0, but we want the derivative. Sorry. We want at 1 the derivative to be 0. So how can I connect stuff for this to happen? So I want local mean. Okay. So, okay, how can I do all this? How can I connect those dots for this to be actually kind of working? Please unmute and tell me, because I think it's easier for that type of problem. So you guys share it with me orally. So how can we do that? So that's a max. That's a local mean. So immediately it means you have something like that in here. You know that. That's your local max and that's your local mean. And at 1, they want the derivative to be 0. So you do whatever you want at 1, as long as we have a 0 for derivative. Anybody? You guys have to help me in those problems. I'm going to start here. What do you want me to do?
Go down to the 2.
Go down to the 2. Then what do you want me to do?
You have to come up a little bit and then go down to the 1.
I have to come up a little bit because I want derivative 0 at 1. Then I come back down here. Okay, and now I have my function. All right, so those are nice problems because they make us start graphing. So this will take care of that. Now we look at the problems where we have to find a critical point. So I will pick some of them, 33. Okay, let me turn the page. Okay. All right, 33, I'll write it and then I read the question. So 33, let me put, we have the function f of x equal e to the x plus e to the minus x over 2. And And the question is, find the critical point of the following functions. Okay, so we need to find the critical point. So let us recall critical point. Okay, since we're gonna hear this word from now to the end of the semester, critical points are the points where. So critical points are the points where the derivative is 0 or the derivative do not exist. Okay, so to find critical point, basically we set the derivative equal to 0 and solve for x because that's where they occur. And we find the values of x where the derivative do not exist. Okay, so the critical point are those points we always talk about, those local max, those are the critical point. Those are the critical point. Another type of critical point we didn't see today are a critical point like this where the derivative does not exist. So to find them, we set the derivative equal to 0 and we look at the derivative. Is there a value for which the derivative doesn't exist? And this will be my other critical point. So it's really boiling down to setting the derivative 0 and solving for x. That's really what it boils down to. So this is my problem, f of x. I need to find the derivative. Okay, the easiest way, because 2 is a constant, is to write this as a half times ex plus e minus x. Okay, because it will be easier. So now the derivative is a half is a constant. Derivative of ex is ex plus what's the derivative of e to the minus x? All right, e to the minus x. Here it's not e to the x, e to the minus x. I have an inside function, which is e minus x. So the derivative is going to be the derivative of the outside, evaluate at the inside, times the derivative of the inside, which is minus 1. Okay, so f prime is a half e to the x minus e to the minus x. So that's the derivative. Now to find the critical point. Okay, we're gonna set f prime equal to 0 and solve for x. Let's do that. So I'm gonna set a half e to the x minus e minus x equal to 0. And now I need to solve for x. So looks really kind of mess up. How can I solve for x this equation? What would you guys start by doing? Any idea? So it's not my regular type functions x involving x cubed, or I factor out or something. It's slightly different. So what do you want me to do? Any ideas? I know it's early in the morning, but we can do that. We've been doing it for the whole semester. First 1/2, we can multiply by 2 across the board just to get rid of the half because it doesn't seem multiplied by 2. Then this will give me ex minus e minus x equal to 0. Okay. All right. So anybody, that's gonna give me ex equal e minus x. Am I right so far? Okay, how can I get my x? So I have x as a power. What helped me to get my x here? Take log both sides, absolutely. It means ln of ex is the ln of e minus x. Okay, and then this could mean ln of ex is in x equal minus x. Now I'm back to something we understand. I bring both to the same side. It means I add x both sides. It means 2x equal to 0, x equal to 0. So my critical point is at x equal to 0. Okay. So that's really, as I said, matter of really looking at the derivative and proceeding. So let me look at other problem I assigned. Okay, I look at 35. Okay, so let's look at problem 35. And then we're going to be doing this whole, as I said, for a while. We're going to be computing critical point to accomplish different goal, but that's what we'll be doing. So let me look at number 30, which one I am? 35. Very good. So here I have the function f of x equal 1 over x plus ln of x. Okay, and we need to find the critical point. Okay, find critical point. So we set f prime, so critical point. We set f prime of x equal to 0, and we solve for x. That's because what the critical points are. Okay, so let's compute f prime equal. Okay, so it's 1 over x. It means x to the minus 1 plus ln. Okay, so let's compute the derivative. Derivative of x to the minus 1 is minus x to the minus 2. It means minus 1 over x squared plus derivative of ln of x is 1 over x. Okay, and I need to solve this for x. So we're going to set minus 1 over x squared plus 1 over x equal to 0 and solve for x. And here we have to be very careful with, we'll see what we have to be very careful with. Okay, how do you want me to solve this equation? So we're solving equation, which is actually very good practice, but I want an input from you. Okay, how would you guys solve this equation? Because we're going to do a lot of those. Okay, you say you need to find the value of x. I said this is satisfied. Now, how would you solve it? Now, in this case, it's kind of clear what the answer is, but you have to learn it in general. How would you solve this if you were me? Power rule, what do you mean power rule? We have to solve for x. Okay, somebody tells me factor out 1 over x. What do you mean by power rule? I'm not finding derivative. I am finding the value of x that makes this expression 0. I'm finding the value of x that makes this expression equal to 0. So how can we do it? Okay, I have one idea on the board. Anybody else? Multiply both sides by x squared. Okay, so your classmates are trying to basically get rid of the denominator somehow. So we're gonna follow. So that's really one possibility. Okay. So somebody's telling me multiply by x squared. Okay, I can do that. So it's gonna give me x squared times minus 1 over x squared equal to 0. And the reason he did this, yeah, I will do that. We can do it several different approach. I will have x squared times that, which is going to give me minus 1. So now I'm distributing, plus x squared times this will give me x equal to 0, will give me x equal to 1. So that's really a possibility. So critical point occur at x equal to 1. All right, so that's one way we can solve this equation. All right, now another way we can solve this, or there are really several ways of solving this one, or we can find a common denominator. Sometimes it's actually easier. Okay, so find common denominator. Common denominator. All right, if I do that, then my common denominator is going to be x squared. X squared is my common denominator. And this would give me minus 1 plus x over. I have to multiply this by x because I have only one x here, plus x equal to 0. Okay, so common denominator is actually a very good idea. Now, how can this be equal to 0? The only way I have numerator over denominator equal to 0 when the numerator is equal to 0. So let us see. So I have a over b. How can this be equal to 0? The only way this could be equal to 0 if the numerator is equal to 0. Otherwise, I cannot have a fraction to be 0 unless the numerator is 0. So if a fraction equal to 0, it means my numerator is equal to 0, means x equal to 1. Okay, of course, we're going to get the same. So there are several approaches to this problem. Common denominator is a very good approach. That's why I made sure I pointed out for us. All right. So I will hold on to the last problem. You guys work on it again. And we're going to work along the same lines today with a slight change of scenarios every time. So the last thing I mentioned yesterday was the following. I mentioned the following. If a function f, and I wrote it as a theorem, if a function f is continuous, it means it just keep moving. There is nothing that stops. There are no jump. Is continuous on a closed interval AB. So that's closed. Then f has an absolute max and an absolute mean on AB. So it will have to have it. There is no way out. We know that in general, a function doesn't have to have an absolute max. It doesn't have to have an absolute mean. That's really in general. But if we have this continuity on the interval, then we have to have it. And the question is how to find it. So how to find absolute max, absolute mean of f on the interval AB, if f is continuous. Okay, so there is an algorithm which is actually fairly intuitive. So there is a procedure we use that is very intuitive. So I will write it, but then I want you to understand where it's coming from. Suppose you have, this is my A and this is my B, right there. And I have my function, which is, okay, let's go up, down, something like that. This is my function. Okay, so the absolute max, so that's a continuous function, and that's my interval AB, and it's closed, so those points are inside my interval. So intuitively, absolute max or absolute mean, where it can occur, where we will have it. This point is not going to be an absolute max, so we're not going to have an absolute max. The absolute max is going to happen either here at the critical point, where the derivative is 0, or it can happen here at the end point. There is no other place for it to occur. So either the absolute max mean occur at this critical point where the derivative is 0, or it have to occur at the end point. So how are we going to find it? So to find it, we're going to do the following. First, we find the critical point. Find critical point of f in the interval AB. These are what I am interested in. I don't care about what happened outside my interval. So that's going to be the first step. Okay, so I find those critical points. Then I'm going to do the following. I'm going to evaluate the function itself at the critical point and at the end point. So step 2 is evaluate. Evaluate means find the value of. Evaluate the function itself, the original function. The function f at the critical point and the end point. Now, what do I mean by end point? What do I mean by end point? I mean A and B. This is what we call, those are the end points. All right? Okay, so we find those critical. We find where the function reached those value. Then we find the value of the function here, 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 and here. And the last step is basically the largest value we get is the absolute max, the smallest value is the absolute mean. So then the largest value we get in step 2, if you want, you can call this step 1, step 2, step 3. The largest value we get in step 2 is the absolute max. Okay, and the smallest value is the absolute mean. So it's a very intuitive process. The smallest value is the absolute mean. Okay, so as I repeat, it's a very, very intuitive procedure, and we're going to apply it immediately. So we're going to take a function now, and we're going to find where it has its largest value and where it hits its smallest value. Okay, and that's important. This is, it has to be closed interval, otherwise there is not even an absolute max and absolute mean. So let me take up 2 examples. So, okay, example number 1. So this is my process. So the first example. Let me take the function f of x equal to the following. Something like x to the power 3 minus 3x squared minus 9x. That's my function. And the question is find absolute max, absolute mean, it means the largest and the smallest, on the interval -1, 5. So this is the interval of interest to me, -1, 5. So we're going to do that. Okay, so the process is, first we find the critical point inside the interval, and then we start the evaluating process. So step number 1, we're going to find the critical point in the interval -1, 5, because that's the only piece I am interested in. All right, so let's start doing this. Okay, so what is f prime? Okay, so this is f prime. F prime is 3x cubed minus 6x minus 9. Okay, now we need to find the critical point. So we have to set f prime equal to 0. Means 3x squared minus 6x minus 9 equal to 0. Now this is a simple equation to solve. Obviously we can factor out the 3, and this would leave me with a 2 here and a 3. And then we need to solve. So this is simple scenario. I have to factor this out equal to 0. So let us compute this. So this is x, that's a 1, and that's a 3, and that's a minus, and that's a plus. I always double check. X squared minus 3x plus x minus 3. So this would give me x equal -1 and x equal to 3. Okay, so we have to, so critical point, x equal -1 and x equal to 3. Very good. Right. Now, once we do that, we have to find the value of the point. So we know that, actually I wanted, okay, I'm sorry, change it to 0.5. Okay, change it to 0.5. I want to change it on purpose, I tell you what. So I'm going to change it to 0.5. My apology for that. And why? So what are my critical points in this case? Because I changed my domain to 0 and 5, my critical points are, because I'm only have to be interested within my domain. So critical point in the interval 0, 5 is x equal to 3. X equal to -1, I wanted on purpose throw it away just to emphasize the idea that we only take into consideration what's inside my interval. So this is not inside my interval, that's why I've changed it, and that's the only one within my interval. Okay. Step 2 is, now I found my critical point. Basically the derivative, I'm done with it, it gives me what I need. Now I need to go back to the function. So step 2 is we need to find the value of the function at the critical point and the value of the function at the end point. So this is at the critical and this is at the end point. And then the largest will be the max, the smallest will be the mean. All right, let's do that. At this stage, this is the function, not the derivative anymore. I'm done with the derivative. So what is f of 3? I plug this back into the function itself. Back to the function now. F of 0 is 0, obviously. F of 5 is 5 to the power 3 minus 3 times 5 squared minus 9 times 5. Okay, so now f of 3, f of 0. Now I'm back to the original function. And now I just basically pick up my calculator, which is right here, because I didn't do the math. And I just evaluating them. So I will have 3 to the power 3 minus, actually that's again 3 to the power 3. So that's cancel each other. So that should give me minus 81, if I'm not doing it wrong. Now this one is, cannot do it in my head. That's going to be 125 minus 75 minus 45. This is going to give me a 5. Okay. So this mean immediately. The largest value is where the function have its absolute maximum without graphing. So the function have absolute max. Sorry, it's nonsense. Yes, the function have its absolute max at x equal to 5, and its absolute maximum is f of 5, which is happen to be 5. So if f has absolute max at x equal to 5, and it's the value of its absolute max, and the absolute max is f of 5. So the largest value is what it take at 5, which happened to be 5 at the same time. Now the absolute minimum is right there. So the function have its absolute minimum. So have an absolute minimum at x equal to 3. And the absolute mean is what the function takes at 3, which is minus 81. All right, so now graphically what's happening? We actually have a very good idea what's going on graphically. This is a 0, and this is a 5. And 3. Those are the important point for us. Now what do we know? At 0, the function takes the value 0. At 5, the function is taking the value 5. And 3, the function is down here. And that's really the tangent line. So my function seems to be going down here, and then actually this is 5 going up to here. So that's how my function looks like on the interval 0, 5. Okay, I'll take up one more problem, another one, because those are the only hard part here. There is nothing hard really here. It's just basically solving f prime of x equal to 0. That's really what's going to be hard. Once you do that, then you just evaluate the original function at the critical point and at the end point. Okay, we'll do one more problem along those lines. Okay, any questions? So one more problem. So I'm going to take the function f of x equal, example number 2. X to the power 2/3. And the question is find absolute max, absolute mean. So absolute max, absolute mean on the interval -8, 4. So find absolute max slash mean. Okay, so that's my question. What's the absolute max, absolute mean? Again, with the same process, we find the critical point, and then we proceed from there. Okay? Very good. So let's get going. First critical point. I'll compute f prime equal. Okay, that's 2/3 x to the power 2/3 minus 1. So it is equal to 2/3 x to the minus 1/3. It means that f prime equal 2/3 1 over the cubic root of x. Okay? And you know, we always have to think graphically in those problems because they help us tremendously. So that's -8 and that's 4. Okay. Very good. Now, the critical point. What are the critical points in this particular problem? So we have to set f prime equal to 0 to find the critical point. It means 2 over 3 cubic root of x equal to 0. Now, to you. Back to you. Can f prime of x be equal to 0? Can f prime of x be equal to 0? What can you say? Anybody else? So if we see carefully, there is no way this could be equal to 0 because 2 over something, there is no way to be equal to 0. So f prime is always different from 0. There is no place where it's different 0. But what are the critical points in this particular problem? What's happening? Remember, critical points are the point where the derivative is 0 or the derivative doesn't exist. Is there a value of x where the derivative does not exist in this particular problem? Look carefully. Look carefully. Within my domain -8, 5, is there a value for x where the derivative is really problematic? Whenever you have denominator, you know, something should come to your mind. Right, at 0, we have a real problem. The derivative at 0 does not exist because it's 2 over 0. Okay, so x equal to 0 will be my only critical point. All right, so that's why I put this problem out to just point out this one. So here, f prime is always different from 0. However, f prime at 0 do not exist because we cannot divide by 0. The function makes sense at 0. At 0, x to the x, that's a positive power, makes sense. The function has a value at 0, but the function derivative at 0 do not exist. So the critical point here is x equal to 0. And the critical point here is not coming from the fact that the derivative is 0, it's coming from the fact that the derivative does not exist. So now I have some issue, something occur at x equal to 0. Now, max and mean, again, the second step is we have to evaluate the function initial function at 0, critical point, and then at the end point. So the end point I gave you were -8 and 4. Okay, I have to evaluate the function. Now, my function, I put it here. Okay, at 0, I plug in 0 here, so I get a 0. At -8, that's -8 to the power 2/3. So it means that's the cubic root of -8 square. Cubic root of -8 is -2 squared, that's equal to 4. Now for 4 is the cubic root of 4 to the power 2, which is, I don't quite know how much it is, but definitely it's less than 4. It's definitely less than 4. So I need 4 to the power 2/3. So it's like a little bit 2.51. Okay. So immediately, that's the smallest value we got. So the absolute minimum occur at x equal to 0, and the absolute max occur at x equal to 5. So we have absolute minimum at x equal to 0. And the absolute minimum, it means the value of it, the absolute minimum. When I say the absolute minimum, it means what's the value of the absolute minimum. This is, I'm talking about the value of the function at 0. Absolute max occur at x equal to 4. The value of the absolute max is what the value, no, sorry, that's nonsense. At minus 8, the absolute max is the value that the function take, which is 4 in my case. Now we graph a little bit. Okay, so we use this info to graph the function. So this is my function right here. My domain, minus 8 and the 4, 0, something occur. Now, at minus 8, the function takes the value 4. At 0, 0. And at 4, the function is going to take the value 2.51. Okay, now we actually don't know exactly how to graph, but I will graph it to you in the correct way to tell you what's usually very soon, actually. The next section, we start learning why this look like this. But the way the graph is going to look is like that. At 0, the derivative does not exist. There is no derivative at 0. So what's going to happen, we're going to have like something like that at 0, and then it would go like this. Okay, and the part why it's concave down like that, it will be what the next section is talking about. But that's how the graph, and that's why we don't have a derivative here. We have different tangent from the left and from the right. We don't have the same tangent. Okay, so finding absolute max, absolute mean on a closed interval, and that's the very crucial, is a relatively a simple process if we do it 2 times and interact with it. I mean, that's really the only place where a function can have absolute max is right there. Critical point or the end point, as long as it's closed. Right. Today we're going to start learning, well, not today, not now. Now what we're going to start doing is the following. We're going to move to section 4.3. And what the derivative tell us about the function. So what derivatives tell us? Tell us about the function. So basically, the derivative will tell us a lot about the function. And now we're going to have to start learning what does it tell us about the function. So today we study what does f prime tell us about the function, and tomorrow, hopefully, what the second derivative tells us. So the question is, what does f prime, the derivative, tell us about f? Okay. First, let us remember a basic fact, increasing and decreasing. So suppose I have a function f. Okay, function f. The function is increasing. That's increasing. Suppose you have an interval AB here. Doesn't have to be closed anymore. Increasing means as the input increases, the output increases. That means basically as we're moving to the right, the graph rises. So that's an increasing function. And decreasing, it means decreases. It means as the input increases, my output decreases. So let us assume this is A and this is B. So I'm not saying A and B included. I'm keeping this quite ambiguous because it doesn't really matter for us right now. Now, so that's increasing and that's decreasing. Now, when a function is increasing on an interval AB, okay, what can we say about the derivative at every point? So if it's increasing, derivative is the slope of this tangent line. So if it's increasing, the derivative is actually positive on this interval. And if decreasing on an interval, my derivative is negative on this interval. So here f increasing on the interval AB, f prime is positive on this interval. Okay, so whenever the derivative of the function is increased. Now here f is decreasing on an interval AB, f prime is negative on this interval. Okay, so that's one relationship between increasing and decreasing. But this relationship is going to be actually going to help us in the following way. If I have a function and I want to know when it is increasing and decreasing and my calculator is broken, basically, I really have to do it algebraically. Okay. So the first idea here we're going to mention is I'm going to just rephrase this. Tells me the following. If the derivative is positive on an interval AB, on an interval, let me call it I. So if the slope is positive, then f is increasing on this interval. So positive or negative derivative is an info about increasing, decreasing. And if f prime is negative on an interval, then f is decreasing on this interval. Okay, so let me now ask you some fairly simple question. Okay, two simple questions. So suppose I give you the graph of a function, and very simple graph. So that's the function, that's the input is f. And let me give you some values, 1, 2. Okay, so that's my function. And the question is, for which values of x is f prime of x positive? Okay, so instead of asking you questions about the function, I'm asking you a question about the derivative. It's simple. So for which values of x is the derivative positive? Quickly, I want the answers on chat. Okay, so somebody tells me the derivative is positive up to 1, and it makes sense because f prime is positive here, positive here, positive here, and after that, when the function is increasing. So for which value of x is f prime positive? Basically when f is increasing. So for x less than 1 or x greater than 2. Or as your classmate put it on chat, from minus infinity to 1 or from minus infinity, from 2 to plus infinity. Okay. Now question number 2 is I want you to sketch the graph of a function. Again, simple questions before we do the algebra, which is going to be tomorrow. So question is, sketch the graph of a function f such that f continuous. It means we don't have jumps everywhere on the interval minus infinity plus infinity. F prime positive on the interval minus infinity 1. Okay, I want f prime of 1 not defined. So we have an issue with the derivative, not with the function. The function has no problem. I want the problem with the derivative, and then f prime negative on the interval 1 plus infinity. Okay, I want you to sketch a function that satisfies all those. I give you 2 minutes. Each one of you should be responsible. I don't see you, of course, but I want to trust that you guys will do the work. So sketch a function that satisfies those problems. It's positive. So immediately, what does it mean? The derivative at 1 is not defined, but the function is defined. f prime negative or minus. What does it mean? So always interpret in terms of the function and then graph it. Okay, so this is 1 here. I want my function to have issues at 1. Whoever is ready, let me know what to do. Let us analyze. F prime positive or minus infinity, it means in terms of the function, it means f is increasing on minus infinity 1. That's how we're going to immediately always interpret the information we have. So it's positive, it means the slope, so the function have to go up. Now, f prime at 1 not defined, it means, you know, we have this kind of picture right there. F prime is negative, it means f decreasing on the interval 1 plus infinity. So now it shouldn't be have hard time anymore. Quickly, because we have to quit, how the graph look like. Anyone? So at 1, we have an issue with the derivative, not with the function. The function is continuous. The function has no issue itself. Quickly, so we can quit. Start in negative, whatever. I start here, for example. And then, okay, peak at 1. So we're going to peak at 1, but we're going to peak like this to make sure we don't have derivative. And then we're going to have it decreasing. So the function would have this funny, like this. All right. Okay, so tomorrow we're going to do those problems algebraically. We're going to start learning algebraically. If I give you a formula, not anymore a graph, how, just by starting from the formula, how can I decide when is the function increasing and when is the function decreasing? Okay, so it will not be graphing. So we're going to do all those problems algebraically. Okay, that's it for today. Please do your homework. Don't fall behind at all. All right, any questions before I let you go? Okay, see you tomorrow, guys. Bye.